and welcome to another episode of FooBar. Here we are back from the summer holidays, and we have a super special episode today because we start with a guest. We are going to talk about serverless and artificial intelligence, like everybody in the world is talking about that right now, so let's jump into the wagon. And for that, I have my colleague, David Boyne, that is going to share one of his adventures into the AI world. So welcome, Dave. How are you doing?
Hello. Yeah, great. Thank you very much. Thanks for having me. I'm doing great. How are you?
I'm good. Back from summer holidays, and this is the first episode in a while. So just for people not to miss me, I brought you in here, so we have double the trouble.
Yeah. Well, welcome back.
Thank you for being here. Maybe you can introduce quickly who you are, why you're here.
Sure. Yeah. I'm Dave Boyne, so senior developer advocate at AWS. So I'm here, to talk about AI story generation. Actually, something I tinkered with about a couple of months ago now. So using like event-driven serverless solutions, coupled that with AI stuff, and then throw my kids in the mix, and then kind of creating stories for children. Believe it or not, which is quite fun. My kids love it. So yeah, I just talk about that, talk about the architecture and the patterns, and then what you can learn from all of this today, hopefully.
Yeah, because at least I cannot talk about artificial intelligence, but artificial intelligence needs coordination and needs orchestration in order to tie all the different bits and pieces. So for sure that we can talk about a lot.
For sure, yeah.
Event-driven is a great way to solve this type of problems. And maybe we can jump a little bit on what is this story generation thing, how you came up with that idea. You mentioned your kids, but maybe
sure,
a little bit more about it.
So I've got some kind of slides, some overview slides here, just kind of setting the scene really. So the whole idea really is every night I'm sat with my kids, try and read them a story every night, right? And it's kind of like this scene, obviously not as cool rooms looking like this, but the idea is pick a book up, or I get my kids to pick a book up and we read the book. Now this is great if the book is kind of new and we've not read it for the 100th time, but after about 100 times it kind of gets a bit boring for me and gets a bit boring for the kids, and kind of need to buy new books all the time. So I'm kind of thinking, how can we kind of solve this, right? So about 4 months ago, all the AI stuff was kicking off, like crazy, and it still is, to be honest. So it's kind of like, how can I use AI kind of models or generation to create children's storybooks? Right? There's a lot of examples online at the time of creating poems and all this kind of stuff. So can we just kind of tweak that a bit and kind of add some prompts in to create stories for children? And that's exactly what I decided to do. So this is kind of me. It's a weird, like Thomas the Tank Engine in the top left. I'm not sure what's going on that. All these images are generated using AI, by the way. And shout that out. So I decided to just decide, can I use AI? Can I use serverless technology and create these kind of books that are different every time? And the whole idea really was like every night when we go to sleep, just before the kids go to sleep, can I get a notification on my phone or something to say, okay, here's a new story that's generated, and using them as the characters or using different scenes and just this new unique thing every time. So I started to hack that together, and then we create this kind of weird and wonderful application that allows us to create these like weird and wonderful books, new books every time. So it's actually worked out really, really well. So it's using kind of event-driven patterns. We're using serverless technologies, and every night at 7 o'clock, I kind of get this notification back, and then we click on the link, the URL, which I'll show you soon, to have this new experience in this new book. So, and I remember showing the kids for the first time, and they were just like, I'm in a book. This is incredible. And someone's reading it out to me. So we're using Amazon Polly actually to kind of read the books out to the children. So just
you even outsource that part.
Yeah, exactly. Yeah. So it's like outsourced dad. So why do I need to be there anymore? Where does it go? Right. So I can automate dad there. And this is it. This is what the kids get every night. So we get a new, unique journey experience, whatever you want to call it, this book every night. It's pretty fun. And you can and the way I've built it is you can give it an array of scenes. So in the example I'm going to show you, we only have like 3 scenes, but you can give like 30 or 40 or 400, 4,000, 4 million scenes if you wanted to generate these.
Those perfect places for your kids, like unicorn land.
Exactly, whatever your kid's into. Yeah, so I put an example today actually about, so you'll see it's me and Marcia doing a stream on YouTube or doing pair programming or a live talk or whatever it is. So put some context there. So yeah, so kids really enjoy it. And then what happens at the end of it, the output is this is what you see. So I created a front end application. We've also got the back end stack. The front end application looks like this. So we have this on the left. We have the generated story. So I tell the AI agent, okay, here are some characters. So that's number 1. Here are the scenes. That's number 2. And then create me a story based on this information. And it does a really good job of just creating, a story with about 3 or 4 paragraphs of this particular thing. And then the interesting thing, what you can do from that, if you're thinking about event-driven applications and extendable applications, you can kind of extend this thing, I guess, forever. So examples here would be like, okay, well, we have the context of the story. Let's give the context of the story to some image generation AI, right? And then the image generation AI says, thank you very much. Here's what I kind of interpreted from what you told me. Here's an image for your story. And that's great. Okay, so what else can we do? We can do generate audio. So here is the story as text. Can you generate me some audio? Right. And then you can just kind of continue this. At the time, 3 months ago, it's kind of all I could think of to get something out. But nowadays, you could do videos, right? AI videos.
Yeah.
You can say, here's a story, here's some characters, do some videos.
Make me a video.
Exactly. Make me a film, make me an hour and a half film and leave my kids there. But it's incredible. It's really incredible things you can do. So that's kind of setting the scene. Have some kind of architecture. We can go into some architecture diagrams. I'm sure what you
I think that's what people are here for.
Cool, yes.
Also the stories.
Yeah, how it's built. Cool. So let's talk about some architecture overview then. I haven't got too many slides. We'll kind of go into some code, show some examples in the console. We'll actually generate a story and kind of view that and see what's happening there. But we'll probably just talk about some of these patterns as we go through the architecture. So again, just to kind of set the scene, every night at 7 o'clock at bedtime. So for my kids, it's about 7:30. They're pretty young, like 8 and 5. I want to generate a new story, right? And then this new story, this schedule triggers something in the cloud, and this thing in the cloud, my application does all this work. And then when it's done all the work, it kind of fires off an event at the back of it and to say, okay, everything's done. Here's your email, Dave. So that's the kind of general gist of how this thing works. And the architecture overview isn't too scary. So we're using EventBridge here. We're using Scheduler. So we'll talk about that in a minute. Using Lambda and DynamoDB as storage. We're using a new feature service that come out at reInvent called Pipes to connect 2 different services together. And then using EventBridge to fan out this event to downstream consumers that something has happened. So what we're going to do now, what I'll probably do is we'll step through these individually, Marcia, if that's okay, and talk about the patterns.
I think there's a lot of very interesting things here that people are willing to see, like the scheduler. I have talked about it when it's launched, but I think it's nice to see it in action. Pipes, I have made like million videos, but here there is a really use case on how to connect Dynamo with EventBridge that is super useful. And the fan out part, I think it's something a lot of people are using, and it's a great pattern. So
cool.
You can start from wherever you want.
Cool, yeah. Start from the start, I guess.
Maybe.
Yeah, it was just a good place to start. So EventBridge Scheduler. So again, remember every time 7 o'clock. Now you can set this up whatever time you want. This is a one-time. It's a repeating schedule. So every day at 7 o'clock, it'll do the same thing.
Your time zone.
My time zone, yeah. So Scheduler is great. It allows you to do different time zones. So if Marcia was to do this, in her time zone, we kind of set this up so she gets it at 7 o'clock, not 8 o'clock or whatever the time works out to be.
I think it's like 9 o'clock for you.
Yeah, okay, yeah. So you'll be waiting for your book for a while.
My kid will be very sick.
Exactly, not good enough. But we have the schedule. So schedule is great. So we can actually target like hundreds of different services and thousands of different API calls, which I'll go into in a second. But in this example, what we're doing is just saying, okay, 7:00 every night, I want to trigger the Lambda function. I want to trigger some small compute that will generate a story for me. And what that story does, it goes off to the agent and kind of generates and does things, which we'll go to in a second. So scheduler, I kind of chucked this one in because I think it's pretty nice. Nice slide here just to kind of give an overview of what this is. So as Marcia was saying, EventBridge Scheduler, we launched this at reInvent last year. But this allows you as a consumer, which I think is really cool as a developer, to actually schedule millions of schedules, right? Millions of like cron jobs or one-time schedules or anything you want to do. And it's great. I think Marcia, you wrote a blog post on this, and I really like the example of what you wrote about there about having users unsubscribe to systems as an example of this, right? So I have a subscription service. Marcia signed up. She wants to stop that in a month's time, but we're halfway through the month. So we can set up a one-time schedule, super easy to say, okay, remove or flag Marcia as unsubscribed in that particular date, right? So not right now, but that particular date. And once you set up that schedule, we can that's it. We set up the schedule, we kind of forget about it, and it's done and it's handled for us.
There's so many use cases, like actually when customers have implemented their own cron on top of our scheduler, like
exactly,
because it's just an important thing to be able to schedule things, and more when you can do it at scale, because the basic quota, like default, every AWS account has 1 million schedules that they can do in their AWS account. And that's a lot.
Exactly, yeah. So it's fantastic. So and on Serverless Land, if you want to check out some scheduler patterns, I think we have over 50 patterns on there actually that we've kind of all open source people have contributed back to. So it's worth checking that out because I think it's fantastic. And as you can see, you can target over 200 services, 6,000 API calls. I think it's more than that now.
Now it's 270 services.
Okay, yeah. So a lot of services. So back to story stuff. This is how the story works. So very simple. Schedule triggers Lambda. Once Lambda is triggered, what I do then is go to 3 different places. So if you think about a story, what is a story made of? We have characters. This is how I designed it anyway. So you've got characters, you've got scenes, and then you've got the story, the output itself. And this is exactly what it does. So we have up here, we've got the characters. So this is just an array of characters. This is an example of Eric, who's on the team, and myself as an example here. 2 characters in the story. And then what we do is we set up the scenes. So it's what I said earlier is about the scenes could be, you could have thousands of scenes, millions of scenes, doesn't really matter because we can scale here. But in this example, we have 4 scenes. So, live on Twitch stream, something goes wrong. Because the agent itself, the AI agent needs the context of the story. I guess you could try without a context. I'm not sure what you get back. You could just say, write me a random story.
Something maybe very boring.
Exactly, yeah. So but being kind of targeted makes it kind of more interesting, especially if your kids are like, my kids are into gaming or their schools. So I could put their like local school in there and their friends and their cousins, and you start mixing, matching these things and just get some interesting things come out. So once you have the characters and the scenes, what it does then is says, okay, it uses the prompt. And as you can see down there, the prompt is very simple. It just says, write a title and a rhyming story on the character's length. So that would be 2 in this example. Main characters are called Dave and Eric in that example. And the story needs to be set within the scene. And then we pass it the scene. And it needs to be at least 200 words long. So we kind of very targeted, very specific on what it needs to be. At least 200 words. Otherwise, the agent might come back and just say, here's 10 words or whatever it could be.
Maybe 200 words is like 3 or 4 minutes story that is enough to keep your kids entertained and go to bed fast.
Exactly, yeah. Can you imagine 2,000 words, 20,000 words?
Here you have a novel.
Yeah, exactly. Could be interesting. Maybe they could read that themselves. So that's what it does. So it kind of gets this thing together and puts this information inside of this 3rd table called stories we see there. Now, what we do then is once the story is created, the Lambda function is done. The Lambda function is just thank you very much, move on with my life. But now we kind of go into the next pattern here. So this pattern here is actually called change data capture pattern, which is kind of one of my favorite patterns actually, because it allows us to react to events happening with our data, right? So we have insert or delete or update events. So an example of what happens here, we have the change data capture on DynamoDB. So we're using DynamoDB streams to listen to this information. So we set this up, and this is all kind of handled for us as part of the serverless kind of offering. And then what we want to do, if you think of that as the source and you think of the target as EventBridge, what EventBridge allows us to do is allows us to kind of fan out. It's an event bus and allows us to fan out an event to downstream consumers. So a fully managed event bus service. Now, this is cool because it allows us to take that single event and then kind of make it into, I like to call them domain events, something, the story has been created, and kind of fan that out into the abyss, into anyone out there that wants to kind of know and is interested in this. Now, at reInvent, again, last year, we launched EventBridge Pipes, which allows us to actually do this point-to-point messaging. Right. So what we can do with pipes is say, here's a source, very, very popular one, actually. I've seen a lot of people do is this pattern here is here's the source, here's DynamoDB, and here's the target. So the target in this example could be EventBridge. And EventBridge Pipes is a service that manages this point-to-point messaging for us, which is fantastic because it kind of listens and kind of forwards that on there.
And it does the filtering and all kind of things, because before customers were doing this, but they had to put a Lambda function in the middle. That added more code, added more complexity. They needed to do a lot of the filtering in there. Now with Pipes, it just does the filtering for you. It does even the transformation of the event for you. So
exactly that, yeah. And I think this is one of the kind of best features I love about Pipes is exactly that, is the filtering and the enriching. So if you think of your message coming from DynamoDB and it goes to its target, if you want to, so I do some filtering. I'm going to show you some code in a minute. If you want to filter out only the inserts or you want to filter out any particular information, we can do that. But the interesting thing too is we can enrich. So when it goes to EventBridge, before it goes to EventBridge, you might want to enrich with a third-party service. You might want to enrich with another DynamoDB table. You might want to enrich with anything almost. And that supports like API destinations, it supports step functions and Lambda. So you can do some very interesting kind of point-to-point messaging between these sources and targets. So if you've not checked out Pipes, again, recommend checking that out. Serverless land, we have lots of patterns there for you to dive deep in various different things. So what happens then after that is the EventBridge. So then we fan out, right? We say into the abyss that a story has been created and EventBridge is then kind of done with it in a way. So the first thing, number one up there, what I decided to do is SNS, right? An SNS topic. And the reason for that is because I wanted a simple way to get an email to my phone. Yeah, when something has happened, I want a simple way to do that. So SNS targets, one of the SNS targets is email. So you can set this up pretty straightforward. I'll use some input transforms there. I'll show you in a minute of just sending the link out to my email. So that's that. Number two, what happens there is we generate an image for the story. So the story has been created. We have all that description, all that data, the characters and everything that's within that story. So again, as I said earlier, we pass that to an AI agent. This is DALL-E as an example here to say, can you create this image for the story? Then what we do with that, we put that into S3, give it a pre-signed URL for 2 days. This is the interesting part too of this design is that stories only last 2 days because once the kids have heard it, we're not going to we're not going to go back to it. So let AWS handle this for us and just kind of manage these things, which is pretty nice. And then number three, what we do down there is, again, how can you extend this? And you think about extensions. So when I first designed this, I stopped there. But then number three, you can just generate audio, right? Using something like Poly. Which worked out really well. So got the story, gave it to Polly. Then I remember selecting the different voices. I was like, I want one that sounds like a kid, so my kids can kind of like resonate with that voice, right? So I'll show you an example. But I think, I can't remember. I think it was Joey. The voice was Joey or something. And
there's so many.
Yeah, exactly. So again, we put that into S3 and then pre-signed URL of 2 days. So again, what's happening here, we're kind of fanning out, doing this kind of processing in parallel, and then I kind of get that email. Now, the reason I kind of decided, the interesting thing here is about the design choices there is what happens if things fail, right? What happens if the image for the story failed or the audio failed? Now, the application was designed in a way, and this is kind of, sometimes I think about kind of event architectures in this kind of way. It's like, how can we still give the user some experience if any of these kind of things fail? So we can still give the user a story without an image, right? And the front end manages that. Or we can still give the user the story without any audio, and the front end just manages that. So these are like...
And I think if you're very fast and you just click the link right away when you get it, you might not have a video, an image, or an audio yet.
Exactly, yeah.
Because as everything is decoupled and it's in on branch, and
exactly.
It was just
and I think that's the thing to consider with these patterns. This particular pattern, if these things are kind of optional, so that's kind of why I decided to go that route. If these things were required, you might want to think more of kind of an orchestration pattern, right? Exactly. To say, okay, I need to do this, then I need to do that, and maybe step functions here would kind of help us kind of manage that.
Yeah, that's a good point, because that's a quite classical question, like why you have not used step functions to do the whole thing. But yeah, you don't need an audio. You have a dad that will read the story for you.
Yes, exactly.
Backup audio.
Yep. And that's piecing it all together. So that's it. From start to middle and to end. And if we kind of map out the kind of patterns that we're looking at here, on the left, we're reacting to events. In the middle, we're using things like change data capture, point-to-point messaging, and an event bus. So I like to think of it as kind of point-to-point to fan-out patterns there, which is super kind of interesting. And then down on the right, we just have pub-sub patterns. So, we're publishing or subscribing downstream. This kind of allows us in, if you think about future scenarios, we spoke earlier about the videos, right? Imagine taking the story and then say, okay, I want to generate a video for this story. Okay, how long do you want the video? 2 minutes. What are the characters? I don't know. Maybe here are some images of the kids that you can use in this video generation thing. So the possibilities are kind of endless, really. And the architecture patterns and the services allow us to easily do that, right? Add another Lambda function on, add some more compute on, or whatever it is we need. So
exactly.
Yeah, it was fun to build.
And that's and I think this is just a great example of how you can use a lot of the things we talk about in practice, in something that is super tangible. So it's super nice to see it. But I would like to see a story.
Cool. Let's do it. Yeah. So code walkthrough and demo. That's good timing. So let me just bring the console. So I'm going to trigger the Lambda function.
First question that my audience might be now thinking about when they see code walkthrough and demo, is the code available somewhere?
Yeah, so everything you see is open source. So we have a blog post on it. I'll share some links at the end too.
I will put all the links in the description.
Yeah, great. So great. So let me just sign into my account. Cool. So we're in my account here. So I'm going to go to the Lambda function. So what I'm going to do here actually is just simulate this schedule.
7 o'clock.
Exactly. So what I'm going to do is come in here, and we can see I have 3 functions. So the one we're interested in is this one in the middle. So I click on that. And then through the console, I can actually trigger this directly like that. Now, it doesn't really matter what the event payload is itself, because the scheduler is triggering this and I'm not using any of the payloads, so we can just hit test. This will trigger that. And then what I'll do while we wait is go to my emails in a separate window. Cool. And then I have something here, which I'll drag back.
You already got an email?
Yeah, so I just got an email on my computer.
Oh.
It had a link in it. I'll probably show you that.
That was super fast.
It was like less than a second, I think. That came up. So here's what we just generated, right? So it's using App Runner. So this is a Next.js front end application.
Is it like a container?
Yes, correct. Yeah. So I wanted to. So I had an app. I used Next.js as my go-to, and I wanted to just quickly put something up and just host something. So I decided to use App Runner, which is brilliant for this, absolutely. So I created a container, point App Runner to it. And the interesting thing too is I gave my container kind of permissions to read the DynamoDB table. So as I'm using Next.js, I'm using the server-side props to go and get the story based on the URL here. And then it gets the story and then kind of returns that back to the front end. And the front end knows how to render that. So it's quite interesting pattern there. But the interesting thing, what's happened here is, Marcia, what you said earlier about the image isn't ready yet, right? So I clicked on it too fast because the image hasn't been done, but the application.
Can you refresh?
So if we refresh now,
see?
Cool. There's us.
That's us.
That's us. Yeah. So this.
I look very surprised. That's normal.
Yeah, something's gone wrong. So this is, I can't remember, the prompt was a tale a day, must be in pair programming. So I think with pair programming, something has gone wrong.
David and Marcia were two friends. We are not friends anymore. Oh, damn.
Yeah, we're two friends. What's happened? Exactly.
I don't know what happened. Nothing good.
Not enough for programming. They often found it in the office hard to work, never stopping. So it's kind of this rhyming story, and it kind of goes down like that. Now, if I play the audio, I'm not sure if we're going to get audio through this or not. I can try.
See? No.
Can't hear that. Okay. So,
but it's sounding.
Okay. Yeah. So yeah, check it out. If you're interested, kind of check that out. But you can see here with the story, it comes down. And kind of, a nice short story for children, I think. I created a background on it, kind of spice it up, chuck some CSS at it, and the magic's there. And every night we get a new story generated while we do nothing. So we kind of async. I like to call it async dad.
That's good because you travel a lot like a developer advocate. So.
Exactly, yeah. So it's just like, here's the email, forward it to them.
Next step is you need to train a model with your own voice.
Yes.
Because that should be pretty easy with event-driven architectures. Switch poly to something that you have trained with your own voice, and then the kids will have that's voice telling their story every night.
Exactly. And then what's next? Holograms, everything.
Then.
Yeah. Yeah, where do we stop?
I'm sure we can do that.
Yeah. But the interesting thing too about this is, so this is kind of I designed it for myself and my kids, but there's no reason why you couldn't, like, in theory, put Cognito in front of this. There's no, in theory, why you couldn't kind of scale this out to, thousands of users, right? Because the users we have the stories, the services will be able to handle that. So just an interesting pattern to consider. So if you had a family and you all wanted to do this, you could fork the repo, maybe create Cognito user pool, just experiment.
And even the databases that you have there with the names and the scenes can be front ends because they are tables.
Exactly. Yeah. So the first page could be, okay, what are the characters' names? Tell me a scene. Press a button.
Exactly.
Here we go.
Everything can be customized, and it cannot be stories. You can do so many things with this free pattern. So that's, I think, what is very interesting of this example is just something very simple, but it's very elegant, all the patterns that are being used there.
Yeah.
Can we see a little bit the code, what you have done there? So when people go to the GitHub repo, they know what they find.
Yeah, sure.
Yeah.
Okay, so when you come to the repo, you'll have, I'm going to try and do it on this screen. Cool. So you have the back end and the front end folder, and then the usual kind of stuff. So in the back end, the first thing you might be interested in is the data folder. So we have characters and we have the scenes. So if you want to fork this out and try it yourself, come to the characters, add your characters in here, come to the scenes, and add your scenes in there. When you deploy the application, it'll actually deploy your DynamoDB tables and actually insert this information in your tables for you as they kind of provision up.
Oh, nice.
So that's all you have to do if you want to try it out. Here, so the back end, I kind of go through some.
I can see CDK, so that's good.
So using CDK, yeah. So I stole one of your patterns, actually, Marcia, which was I split my CDK into 3 separate things. So I got my my tables, so provision the tables. This is what this part does here. And then my front end, I kind of separated that out into its own CDK part there. And then the back end here. It's kind of made it more manageable for me. And I can imagine if teams are building this kind of way, it'd make it more manageable for them, for sure, I think.
Yeah, I think so.
So yeah, so I'll quickly kind of give an overview of this, but so we're using Open API, so we get the key from the secrets. We create our own event bus, so we use AI stories. We've got the event bus there. We create a bucket for the audio. So the audio and the images, believe, go to a bucket, so we can kind of reference that later in the front end and pull that information down. We have the tables. We showed that in the architecture diagram. We've got the email topic. So we're using SNS, as I mentioned. I'm emailing myself, so I just create a topic here so I can do that. I add a subscription, the email subscription with the email, which is all configurable. So you can go to the config file of the project and add your own email in there to kind of host that, which is cool. Usual stuff here. So we provision a new Lambda function. So we're using Node.js function here. Give it some kind of defaults and some environmental stuff there.
Yeah, that's the first Lambda function, the create one, the ones that get invoked.
Right, yeah. And then we got a next one here, which is the images. So we generate the images using, again, the Lambda function. Scroll down here, we've got the audio. So these are the 3. So the first one was create the story, and then these next 2 are the consumers of the event that the story has been created. We have some policy stuff. So our function can actually use poly and create permissions to create the thing. We give it some write access to the buckets. And then down here, we got these, we got a rule, we got an EventBridge rule. So we're actually filtering out, this is the event pattern. So for those not familiar, so we have the events. We have the events come into event bus, and then we want to route them to downstream consumers. We do that using rules. So then when a story generated event has been triggered in this particular domain, which is the AI stories, then we'll trigger the downstream consumers and they'll be triggered based on that. So very basic rule here. And then we have targets. So these are the consumers. The targets are consumers. So as I just mentioned, the rule gets the event gets triggered. And then we have these 3 different things. We have a Lambda function, create the images, the audio, and then we have the SNS email. So actually creating the string that gets added to the email here. So it will say a new story has been created on the front end URL. That would be your hosted app runner URL in that example. The story ID, and then we kind of get it from the path of the event. So we're kind of concatenating this string from information from the event that we get, which is cool, which works nice.
But there is very clear the fan out pattern. You can see the same rule has 3 different targets and all do different things.
Exactly, yeah, exactly. Makes it easier to kind of read, I think, with CDK like that. And then the schedule. So here's very simple schedule. We have the cron time is in the config. So this is you can see that's 7:15. And then we have the target. So remember, you have your scheduler and then you have a target. So what is it you want to target? And we say, okay, we want to target this function. And then here's the role to
invoke the function.
Yeah. And then that's that. We have a bunch of permissions down here, like read and write to the tables and various things like this. And then we have the pipe. So this is the EventBridge pipe. So what we do here is we create the pipe, and we have the source and we have the target. So the source is the stream, the DynamoDB stream. So we're saying, listen to all these changes on the database, and we have this stream on the left, and then the target on the right is the event bus. Okay, so we're saying, listen to all these changes, all the things that we're interested in, and then trigger the event bus. And then what we do down here, we spoke about this earlier too, is we kind of transform that payload for EventBridge. So we use something called input transforms here. So what we can say from Dynamo is like, thank you very much. So EventBridge pipes will say, thank you very much. I have this object, and this object is a DynamoDB kind of object, and it looks in a particular format in a particular way. And then we forward this onto EventBridge. And what we do, what I decided to do here is say, okay, just map this into a domain event, into an event I can make sense of. I'm not interested in new image objects. I'm not interested in this stuff. And I think this is a good pattern to follow, because if you can raise events straight from Dynamo and stuff, but as your consumers consume these events, they know about the implementation details, right?
They don't need to know about Dynamo,
Exactly.
because also Dynamo is very verbose. They have the string there, and it's just so hard to make sense of those events if you don't know.
Exactly, yeah. So I think that's a nice clean pattern when you're building event architectures. You just decouple these domain events. If your consumers knew about this DynamoDB model, this data model, then we replace DynamoDB or we make changes or whatever. We just got this coupling between these downstream consumers that are somewhere that we don't even know about, right? And then we have this kind of model over here. So,
and you could test this very easily now, because now your event for your event bus for your fan out is something very small, blurry, clear. You can basically start sending events directly to your event bus as a testing mechanism, and then test all the fan out without testing the, Dynamo part and the first part.
Yeah,
you might be sure that works. So it's kind of very good to have clean interfaces.
Exactly. Yeah, I think that's worth shouting out. 100% is, as you're building a new consumer, you already know what the event payload is. It's an ID, a title, a scene, and description. So I don't need to know about anything else. I don't need to know about pipes. I don't need to know about DynamoDB or the scheduler or the Lambda. I can just trigger an event, test my workflow, my consumer works, and then build it up like that. Makes life a lot easier, I think.
Yeah.
And then down here is, again, we got a simple filter pattern. So Marcia was mentioned earlier, we can filter out the events before they come into our target. So all we're doing here is just saying we're interested in inserts only. So new items, that being exactly.
Yeah.
And that's it. That's the majority of the back end. About 200 lines of CDK, and kind of works very well. So I think what else? So you see here we have the stories, we have the functions there, so we can create the story. This is all open source. You can dive into there.
Yeah.
We can see the prompt there. Create it. We talk to the AI agent. We set some TTLs, things like that.
But the cool thing here is because everything, like in this architecture, basically you have only 3 Lambda functions, and these 3 Lambda functions are calling different third-party services. So if tomorrow you want to change, now you're using OpenAI, but for example, you want to change to Bedrock, you can basically replace that Lambda function with one that is calling the Bedrock API, and woof, you're ready. Or you want to change DALI to Stable Diffusion running in maybe your SageMaker, boom, you change that Lambda function to something else. So the rest stays exactly the same. And that's the cool thing of this type of architecture. Everything is very coupled from each other, and it's easy to change.
Exactly that. Yeah. So, if anyone's watching this and you want to put pull request in to do something else with some AI models, feel free. Be interesting to see what people can do. But as you said, majority with the event architecture patterns is, that's the beauty of it, is that consumers come and go. We can change this consumer. If we don't want images or we want whatever is the movies or more detailed things, we can kind of do that really easily, actually.
Yeah. So
that's a great pattern. Trying to think what else we got. That's the majority of it. We got the front end down here. So again, the front end, just a Next.js application. You can check that out. It's just hosted with App Runner. So you can dive deeper into that if you want to do that or make any changes.
I heard a little bird there that you are working on some really cool Visual Studio plugin, maybe.
Yeah, sure. So I've been spiking out. So one thing I want to do, one thing I've been spiking out is kind of how we can bring some more like visualizations closer to the code, I guess. So an example here, hopefully this works. Let's have a look. So here it is a thing coming soon, which I called the Serverless Land Toolkit. So VS Code extension. And what this allows you to do is actually, once you install it, the first initial release anyway will be of Amazon EventBridge. And then you can click on event buses and dive deeper into the event bus, see targets, see rules, visualize event buses, interact with them, because which is great, and it allows you to kind of visualize what's happening with producers and consumers and rules and input transformers and all this kind of greatness. So I can show you an example. Hopefully this works. It's the demo gods.
Demo.
Here we go. Oh, it's loaded. But let me just try and get rid of that. So this is all in VS Code. So you just seen on the left, I clicked on the event bus. This is the AI stories event bus actually. And this opens in a new tab. And then what we can do here, we can kind of zoom in, zoom out into this. So here's the AI stories event bus, and you can see it's got one rule. So if you had multiple rules, it would tell you. Schema discovery is turned off. So this allows us to automatically see schemas on the event bus. So if you're doing lots of events, kind of recommend checking this out. A fantastic way to see schemas and understand what's in the payloads themselves. And then archives are just turned off in this example. I don't want to archive any kind of events at all. And as you go down on the right, you can see the rule here. So this is the rule I just showed you in the code. So if you kind of zoom in again, we can see here, okay, so we have the rule, and it has 3 consumers. So this rule has 3 targets. We have the event pattern.
This is really cool to see the event pattern there, like JSON.
Yeah, so we can see exactly what's coming in. So when the event matches this, and this kind of animation is meant to simulate events, when the events come in here, we can kind of see, okay, where are they going? What are they doing? As we go over to the right, we can see here we've got the Lambda function. This is the AI stories generate image one. So this Lambda function here, this target, does not have dead letter configuration set up. In this example, if it did, it would show that, and it'll actually show you another node, which is your dead letter configuration, your queue, for example. Yeah. Custom retry policy is not set up, so you get the defaults out of the box with this. For each node, you can kind of click here and kind of open in the console and do things with that.
And you can see the Lambda function, for example.
Exactly. So that clicking this will open it directly, the Lambda function, so we can dive deeper. And then down here, we also visualize input transforms. So here, the event is coming through to the target, but before it reaches this particular target, we're actually transforming the event. And you can see this by looking at this. So we have the input path. So we put in the detail ID to this, which is from the event. And then the input template that we use is the message that we get inside of SNS email. So it'll say, hi, Dave, or Dave, here's an AWS notification. Here's a new story created. Here's the URL, and here is your story ID. And then down here, we can see that this is now ticked because we have event transformation on there. So this is... Yes, basic example cool. Here. So what I want to do in the future, so if you're interested in this, hold tight. I am when I'm back from holiday, I want to kind of release this on the marketplace and get people's feedback. So if you've got any kind of feedback on this, any ideas, feel free to kind of reach out to me. One thing I want to do, things like testing rules as an example, or trigger an event directly onto a rule. So click this. Why can't I click this and say, okay, trigger an event, a test event, or whatever that might be?
That should be cool.
On the left, we can actually dive in. So if you go into rules, you'll see that the rules launch here. The targets, this is a CloudWatch target. I can actually right click on a rule, here, and visualize the rule itself. And hopefully this works. There we go. And you can see this is actually, just visualizing rules, visualizing event buses rules, anything that you want. So yeah,
well, that's nice. I'm a fan of everything that is in Visual Studio Code because I get distracted very easily. So for me, not leaving the IDE.
Yeah, I think so. Yeah. So I've already started using this tool myself as I'm kind of building stuff, building demos, and I want to quickly see what's going on. So I just launched this. I know other people on the team are actually using this at the moment to help them build stuff. So yeah, that's that. It's a quick shout out for that tool.
That's awesome. So we are waiting for that one. And I think that's kind of it for today. I know you are cooking something else for the next months that you will release soon. Maybe you want to give a little teaser of the last bit
Yeah,
of how you're using AI and serverless.
AI and serverless. Yeah. So I have something else. Yeah, something quick actually. I was. Let me get back up the demos. So this is kind of more AI stuff. Here we go. So I kind of want us. So I don't know, Marcy, if you've ever had. When I was grew up, I had these books, and these books said to me, they're adventure books. So it would be like, okay, welcome to the land of whatever it is. You have a choice to make. Do you go to page 10 or do you go to page 20 based on what you want to experience? So you go to page 10. And when you go to page 10, it's like, okay, I've just met someone. Do I go with them or do I stay and whatever it is? And then you end up either game over, your character's died or got lost or whatever, or you make it to the end where it's like a different ending each time. So I kind of wanted to take that experience and use AI, Next.js, the front end stuff, and see, can we actually train a model? Can we use prompt engineering to actually do this and create this kind of experience? That's exactly what I started looking at. So I'm no AI expert, by the way. That's a disclaimer. I just think
We're serverless experts,
exactly.
but no.
Yeah, so I kind of just tinker where I can and learn some stuff. But I come across LangChain, which is super popular open source AI stuff. And what LangChain allows you to do, very interesting, allows you to do memory. Now, why would you be interested in memory if you use things like ChatGPT before? It allows the agent to store historic stuff, information, prompts, whatever it is, right? So an example would be, rewrite this paragraph for me, and it does it, and then you say, no, rewrite again, please, and it'll do it. It kind of holds that state. So with memory, it allows us to do interesting things with this game idea, this adventure idea, because what I decided to try and do is say, okay, if I can set up the agent to be a games master with a particular scenario, and the games master reads the scenario back to me, I can store that scenario in memory and then just go back to it and say, select option 1, select option 2, and things like this. And this is what it is.
So you're playing Dungeons and Dragons with your
pretty much
kind of
pretty much, yeah. So what happens is here is basic kind of architecture here. And it's very fascinating actually how you can build an app. I found it fascinating how you can build this app without writing code, like too much code. Like there's no business logic in there. The AI Games Master is the business logic, which is very fascinating. So here on the left we have the user. We start a game. The AI Games Master will know what to do. I'll show you the prompt in a minute, and then it will store some information, the game ID in DynamoDB. That's memory. When the user comes back and says, okay, I'm going to choose option 1 or option 2, imagine this is like page 10 or page 20. The AI Games Master knows the historic context because it has the memory, and it'll say, okay, you've chose option 2. Now I'm going to take you down to a volcano and whatever. So pretty interesting stuff. And then this is the prompt. This is the prompt that you see. So it's very kind of targeted, very specific here, but it says, you are a games master. I am an adventurer called whatever your character's name is. You're going to create an adventure for me. It'll be 5 levels. I have to navigate through all 5 levels of the adventure. Each level of the adventure has 3 options, and they can advance me to the next level or kill me. And that's the important bit here. It's your job to randomize these, but at least one must contain the correct route forward. My task as the adventurer is to get to the end of the adventure without dying. Let's start the adventure, right? We can kind of read that. And it returns some JSON back. Now, this was before, I think there is something new called functions out now. So you can actually give it schemas and functions, and it will return the object that you want. This was all before that. So I'm telling it, I'm targeting it, saying, please return JSON, please return it in this particular format, please return JSON. And you see that over and over again, because sometimes it bugs out and does wild, return some wild stuff. But the output is very interesting. So once you get that, once you couple that with a Next.js application or a front end or whatever you want to build it with, you can start seeing some interesting things. And I have a video here of that, and I'll quickly just go over that now. So this is, I called it Serverless Quest because I want to host it on the serverless infrastructure. And the idea is that every event is unique for every character, every time you interact with this thing. So over the video starts, I'll just talk over this. So what happens when you start the adventure, you enter your character's name. So I'm not very creative. I put David in here. And then this is it. The AI agent is now triggered. So we made an API call to start the game. AI agent says, thank you very much. I'm going to build this scenario for you. So this is all the business logic is like in this AI agent. It's like nothing is coded. It's just a prompt.
So everything is in the front end.
Exactly, yeah. So it's like, here's the response from the AI agent. You got some text, you got a level, and you got 3 options. So as a user, as the game, what do I prefer to do? Okay, I'm going to follow the river downstream. So I tell the AI agent I selected option 2. AI agent has the memory and now says, thank you very much. You follow the river downstream, the sound of rushing water gets louder with each step.
You're still alive.
Exactly, you're still alive, right? And the agent tells you you're still alive. So attempt to cross the rapids. So we attempted to cross the rapids now, and the agent is randomizing the next place. The agent is randomizing if you're dead or alive. We made it across the rapids. Yeah, well done. The air is crisp. We're kind of going down this kind of adventure. As we begin to kind of climb the slope, you hear distant drums. What do we do with the drums? Do we follow the sound of the drums?
So you were very lucky when you were recording these things,
exactly.
Because you got a random thing and you are still alive.
Exactly. Yeah, I think I die here. So it's like we find drums. What do? We see people. They tell us to join in, right? So we decided to join in the circle, and I think the AI agent now kills us because we made the wrong choice. There we go.
Oh no!
Yeah, you feel strange, almost drugged. Suddenly, the drum beat transforms. Yeah, this is amazing.
Yeah.
This is the kind of stuff. This is stuff
I can play that for hours.
Yeah, exactly. Just change 5 levels to 100 levels and see if you can make it down to the end. There's some random thank you slide, but yeah.
Well, that's a good slide because we need to round up now. But I think this is a great example, everything you show today, how serverless can power artificial intelligence. Because yes, artificial intelligence is here to stay, but we still need to orchestrate it and coordinate things somehow with it. And we need to talk to it, and we need to get things into users, to create these user interfaces, to create these kind of applications that do things and coordinate things like putting the image, the video, the summary, whatever you're doing, like together. And serverless is a great thing and a great technology to do it. So you have showed so many things today. So
yeah, it's been, and this is the tip of the iceberg, right? This is this was done about 3 months ago from today. But the space is moving so fast. And as you mentioned, that serverless technology is fantastic for this because it allows us to, step into some small compute to do something and then step into some orchestration or some events and do something. So it's fantastic.
And you need to build very complex things. Everything is very done by AWS. AWS will take all the heavy lifting for you, build like 3 Lambda functions, and boom, you're done.
Exactly, yeah.
So
it's incredible, yeah. I'm super excited, to see what's next, right? What people do.
If you're interested in artificial intelligence, you definitely need to learn serverless. That's kind of the TLDR of this video. So thank you, Dave. Now in the screen is your Twitter, your name. You can find you in LinkedIn, in Twitter, and I will leave all the links that you shared today in the comments of this video, in the description. And when the plugin is available, I will make sure that people know about it.
Great, thank you very much. Thanks for having me. It's been fantastic.
Thank you. I'll see you in another episode of FooBar. Ciao, ciao.
Bye-bye.